Hello everyone, my name is Rachit Jani. I am a first year undergrad student in Data Science and Artificial branch at IIT Roorkee. Today I am going to discuss the problem statement to dynamically allocate memory to an array. So first we will look into the overview of today's discussion. What is the major issue faced while using an array? Understanding memory and its types. How stack memory is different from heap memory. Learning how to access memory from heap using pointers and operators in C++. Try to run a code in Microsoft Visual Community using an example of array and an 2D array. So now we will discuss what are the major problems faced in arrays. So an array is a set of memory in which data is stored. It helps us store large data in an ordered manner. But the main problem while using array is that we need to predefine its size, as size of array takes only constant input. We cannot take size of an array as an input from user. This limits the usage of arrays. Now we would look into the below code template, which would show us exactly what error is shown while taking taking size as an input from user. So here we are defining an integer n, and we are taking it as an input from the user. Now later on we are assigning n as the size of array, so it is showing error, and the error argument here shown is expression must have a constant value. The value of variable n cannot be used as constant. The main reason behind the argument that value of variable n cannot be used as constant is that we are taking n as an input from user, so it might vary on a very large scale. That is, it might be 1, it might be 1 million. So it does not help the array to allocate memory accordingly. As a result, it will show an error. Now in order to tackle it, we will use dynamic memory allocation, but for that we need to first understand what memory is and what its types are. So memory is a location or a place assigned to a given variable to store its data. It's of two types: stack memory, heap memory. Stack, it is relatively small set of memory which is easily accessible. Heap, it is large set of memory which is not directly accessible. We need to call it using the new function. Now we will see the points of difference between the stack memory and the heap memory. So stack memory is organized in a last in first out manner, while heap memory is more flexible and allows for dynamic memory allocation. So this point mainly says that the stack memory is in an organized manner, that is, we can its allocation cannot be according to users convenience, but in contrast, the heap memory is much more flexible and can be allocated according to the user's convenience. That is, we can allocate for suppose 10 integers, 11 integers, or so on, 1 million integers from heap memory, but we can't do so for stack. Now the second point of difference is that memory allocation is done automatically when a function is called and deallocated when the function exists. But in heap, memory is allocated and deallocated manually using the operators like new and delete. So in stack, being an organized form of memory, the process of calling and deallocating process of allocating and deallocating is much faster, and hence it is done automatically by the compiler uh, when the function is called. But in case of heap memory, we need to call, as its size vary, we need to call it using the new function and define its size, and then we need to use the delete function to deallocate it. Now stack memory is typically smaller in size compared to heap memory, while heap memory is quite large in size. Now the next point is quite important. It says that lifetime of stack memory is tied to the scope of the function. Once the function exits, the memory is freed. The lifetime of heap memory is managed by the programmer. It persists until it is explicitly freed. So this point mainly says that stack memory is associated with the function. So when when a function is called, the stack memory is immediately allocated, the function is executed, and then after the execution of function, the stack memory is immediately deallocated. But in case of heap memory, when we dynamically allocate some memory, it is and after some time, if we execute a function, so the allocated memory would pass through the executed function, but it will not deallocate itself, and it will remain as it is even when the function is not called or not executed. So we need to use the delete operator to free that memory. Now Access to stack memory is faster due to its structure and locality of reference. Access to heap memory is generally slower due to potential fragmentation and the need of pointer dereferencing. This point says that stack memory is relatively faster than heap memory because it's well organized. It's as in the first point it is said, it is in last in first out manner. So uh, its location is fixed and we just need to call it. So it's faster and easier to call stack memory. But in case of heap memory, it is first allocated using the new function. After that, it is given a certain address in which it is stored, in which its location is stored, and then it is available for usage, for storage of data. So overall it reduces the speed of processing. Now we will learn how to dynamically allocate memory using pointers and operators, that is new and delete operator. So dynamic allocation of memory to an array is done using pointers and new operator. You can see it in the below template. So here a template is given, double asterisk a is equal to new double n. So here a is a set of memory of size n, whose size n, where this n size of memory is taken from heap using this new operator, and it's of variable type double. So overall we are defining an array of variable type double of size n, and we have taken its memory from heap memory. So the memory allocated would remain allocated even if it is never called while running the program. We have discussed this point in the previous slide that allocated memory would remain as it is if we have not freed it manually. In order to deallocate the memory of array, we use the delete operator using this template: delete double square bracket open and close a and semicolon. This basically deletes all the memory associated with with a, that is the that is of size n. So uh, so this overall frees the memory that was previously allocated using the new function, new operator. These are all the same points that we have discussed previously. Now we would look into the code for a 1D array. In this code, as we can see, we have taken the size of array as an input from user as a variable size, which is of integer type. Then we have defined a array a of size, which is of variable type double. Using the new function, we have allocated us an array of size integer size from the heap memory, and then we have taken its input from the user. Then and for each and every element of the array, and for correspondingly we have taken output for each and every element. Now we have used this delete operator to free the allocated memory that was associated with array a, and so here it is written, we are using delete function to clear memory allocated from heap. In stack, memory is cleared every time after the code is run, but in case of heap it remain as it is. We need to clear it manually. So it also says about the point that we have previously discussed. So let us now try and run this code in MS MSVS community. So as you can see that here is our code that we have discussed just now. So let's try and run it. Here we have just we have allocated the memory to array a and then deallocated it. Now let us see how our code runs. So we need to enter the size of array. Let us say we enter it as 6, 1, 2, 3.14, 4, 7.25, 2.78. So as you can see, we are getting output as it is. It is not showing any error, and the memory is also deallocated. Now let us see an now let us see another code with the example of two-dimensional array. So in here we have taken inputs of rows and columns. So in this case, while dynamically allocating, we need to use a pointer to pointer, as we are having two different two different uh, inputs from user for rows and columns. So we need to dynamically allocate memory two times. So first time it's uh, it's allocated in form of pointers, that is int star rows and uh, int star star a. So here star a corresponds is an array with addresses of star rows, rows numbers of row. So and in the subsequent step, that is this for loop, uh, here we are defining for each and every row a certain number, a new that new memory, that is the size, that is of size calls, and this memory is allocated dynamically from heap. So basically it is a row times columns matrix at the two-dimensional matrix. This whole template represents the memory allocation for the 2D array or matrix. Now we have taken elements of array as an input from user. In this step, we have given the output of each and every element of the array. So there are two for loops, one for rows and another one for column, but its dereferencing is quite an important concept to understand. So for the outer for let us say we are discussing for int I is equal to 0, then if we move into the inner loop, uh, it is int j is equal to 0, j less than calls j plus plus. Now for j plus plus, we are taking output of elements of arrays in using the dereferencing operator. Here asterisk time bracket asterisk a plus I plus j represents how each and how output of each and every element is taken. So for I is equal to 0, it represents the first row, and subsequently star a represents the dereferencing of first row, that is a0. And then if we take j is equal to 0 for first step, then it represents the element a00, and address of element a00, and dereferencing it represents the value stored in that address, that is a00. So subsequently for j is equal to 1, it will show the value of a01, j is equal to 2, it will to show a is equal a02, and subsequently till j is not equals to calls. If j is equal to calls, this loop is completed, and we move forward to int I is equal to 1, that is the second row. So it would be the, so the star not star asterisk a plus 1 would represent the address of second row, and plus j represent for address of second row's first element. If j is equal to 0, it would represent the address of second row's first element, and asterisk of that address would represent the value stored in second row first element. So this is how we are taking output for each and every element of the array. Now we are using the delete operator for two differently allocated memories. One is for rows and another one is for columns. So for in this for loop, we are first deallocating each and every for the memory associated with the columns of each and every row, that is we have assigned over here. Now, after deallocating for each and every column, we move forward to rows. So we need to deallocate using this template, this delete square bracket a, and after that all the memory is deallocated and the program is successfully run. So we will also see it by running it in Microsoft Visual Studio Community. So yeah, here is our code. Here is how we have dynamically allocated our memory. Here is how we have freed our memory, or say deallocated our memory. Now let us try to run our program. Let us enter number of rows as 3, number of columns as 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So as you can see, the array is displayed over here without any problem, and the memory is also deallocated accordingly. So our program is successful. All right. Thank you for listening. Bye bye.